One. The problem I'm just going to discuss right now is a nice fusion of geometry and initial calculus. This problem was asked in IIT JAM exam for mathematics in 2024, where the problem says find the limit of the capital Rn divided by small rn whole to the power n square as n goes to infinity, where the Rn is the radius of the outer circle and r small I mean small rn is the radius of a of the inner circle of a regular n-gon. Okay, so before diving into the problem and before considering it in a n-gon, which n can be anything, let's simplify the problem. Suppose instead of an n-gon, I'm just considering a pentagon like this. Okay, although the picture is not very clear, okay, let me erase it and make re-sketch it. Just a moment. This is how a pentagon should look like. This red circle is the outer circle of this regular pentagon, and this green circle is the inner circle of the regular n-gon or the pentagon, whatever you can say. So this is the outer circle, and this green circle is the inner circle. Okay, now if this is the center, then the outer radius would be like this. Let's use another color. This is our Rn, and the inner circle or the inner radius would be this one, the place where the circle is touching, the inner circle is touching the n-gon. So this is our small rn, I mean the purple line. Now observe that I'm just drawing another outer circle, I mean outer radius. So since this entire angle is 2 pi and it is divided into 5 equal sectors, then this angle will be 2 pi by 5 in this case. If it was a regular n-gon, this angle would be 2 pi by n, because in that case this 2 pi is getting divided into n's equal sectors. Okay, so I will be talking about it a little bit later, but just for the sake of simplicity, I am denoting it as theta. Remember, later on we will get theta equals to 2 pi by n, which is right now in this particular case it's 2 pi by 5. Now in this case, although we have considered a regular pentagon, but you can check by yourself that in any case, I mean, doesn't matter how many sides the polygon has, you can check it with a triangle, with a square, with a regular pentagon, regular heptagon, regular hexagon, octagon, and whatever. For any regular n-gons, you will find this triangle. You will always get this triangle, this guy. Okay, let me use another pen to mark it in a better way. This triangle. The triangle that whose two sides are capital Rn and has a perpendicular of small rn. So, but this theta will differ with n. Like if in this case, since it's a pentagon, it's just divided by 5. If it was a triangle, it would be divided by 3. If it was a hexagon, it would be divided by 6, and so on and so forth. So I just need to zoom in this triangle and cut it outside, and examine this one, and that will be sufficient to approach our problem. These are these were our Rn, and the green line is our Rn. Okay, great. Now observe that we assume this entire angle as theta previously. Now we will just simply take this angle, that would be theta by 2, and if that is theta by 2, this angle will be 190 degree. Okay, now we have a more simplified picture. That is, instead of having both the sides, I'm just interested to take the upper triangle. Okay, so let's draw. Okay, great. This is our Rn, and this angle theta, I'm sorry, this is basically theta by 2. So from basic trigonometry, we can say that Rn by Rn is nothing but sec theta by 2. Is that clear so far? If it is not clear, you can pause and review the previous parts of the video. Okay, great. Now, as we had already figured out that theta should be 2 pi by n previously, so it would be sec pi. I'm sorry, I'm just writing pi by n because the 2's will be cancelled out. All right. Okay. Now there's nothing to do with geometry or trigonometry anymore. Now it's time for limit to take the action. Okay, great. Now we are basically finding the limit n goes to infinity, Rn by small rn whole to the power n square, which is limit sec pi by n whole to the power n square. Obviously n goes to infinity. Now this limit, now figuring out this limit does not seem any more challenging, because we will simply consider this guy, the entire term, with something. Suppose my favorite structure is like the omega, the Greek letter. You can assume you can use any letter or anything you want. So omega equals to sec pi by n over n square. That implies log omega equals to sec I'm sorry, it's it's simply log sec pi by n, and there is a n square outside. So we can write it like log sec pi by n divided by, entire term divides by 1 over n square. So if we are evaluating this limit log of omega is equals to limit n goes to infinity log sec pi by n divided by 1 by n square. Now we will do another substitution over here, that is we will simply write this 1 over n square or 1 over n as phi. So put 1 over n is equals to something, suppose something like m. Okay, so this figure will be limit m goes to 0 sec pi m over m square. I'm sorry, there is a log outside. Now observe that both the terms, the numerator and the denominator, both the terms are tending to 0 as m goes to 0. So here we will apply the L'Hopital's rule. So we will differentiate both the numerator and the denominator. So in the bottom there will be 2m, and on top we will have this term. After using the chain rule, now observe that this cos pi m and sec pi m will cancel out, and we will have limit m goes to 0 pi by 2 sine pi m by m multiplied with sec pi m. If you have any doubt here, it's nothing, just the calculation. So you can pause and calculate by yourself, or you can re-evaluate it by yourself as well. You will get the same result. Now this part is quite similar to us. It's a very well-known limit, that is sine x, and that is a limit sine x over x, where x goes to 0 and this limit becomes 1. So the only difference is there is a lack of pi. So we have to bring a pi over here forcefully. Yep. And to do that, I'm just taking one pi over here and squaring the pi on top. Now observe that this limit goes to 1, this limit goes to 1. So the only thing is left over is this pi square by 2. So this limit is simply pi square by 2. So what we are getting at the end of the day is limit log of this omega is nothing but pi square over 2, and which implies limit omega is equals to e to the power pi square over 2. Now that is our desired limit. Limit n goes to infinity, capital Rn by small rn whole to the power n square is nothing but e to the power pi square over 2. And this is what we try to figure out at the beginning, and I guess that's a good place to stop.